Hello everyone, welcome to this week 3 lecture on polymer materials in additive manufacturing. In the previous lecture, you would have seen about metal materials in additive manufacturing by Dr. Alankar. Here we will concentrate on all the type of polymer materials which are available for additive manufacturing. And this is the agenda for our session today. Initially we will see about the introduction to polymer materials in additive manufacturing. Then we will see the categories of polymers which are available, and then we will see about the different type of thermoplastics and its applications and its challenges in getting it 3D printed. Then again we will see about different thermosetting plastics which are available, and finally we will see about elastomer materials. Now getting into the introduction of polymers, usually we would have seen a lot of polymer materials in our real time, and again the same type of polymer materials are getting into additive manufacturing as well, and we could able to see it's being used in different kind of applications and different type of technologies as well. So let us get into why polymers are very popular in additive manufacturing. I could tell you that it is the same reason why polymers are very famous in traditional type of manufacturing methods, and we could see three major properties which is making it very popular in additive manufacturing. Is first one is versatility. Here we could able to use these polymers for low cost prototyping as well as for high performance end use parts. So being a very basic level or a very high end level, this versatility is making the polymers a very good competitor in the additive manufacturing landscape. And the second category is lightweight. We could see that it has got a significant weight advantage basically, because when it is compared to its counterpart metals, where we could able to get a very huge weight, but certain industries like aerospace or automotive, which are very weight sensitive, that means they require a very lightweight components for their applications. In that scenario, they would like to use polymer materials in certain type of components. And the third thing is cost effectiveness. When it is compared with metals and ceramics, polymers are like more and more affordable, and it is not only in the aspect of raw materials but also in the processing cost. The machineries which process these polymer materials are also very cheaper, because when you take machineries like FFF, it's way more cheaper when it is compared with its counterpart like ceramics or metal machines. So the cost effectiveness also comes into the picture. And let us see the categories of polymers in additive manufacturing. We have three different categories available here. First one is thermoplastics, second one is thermosetting plastics, and finally we have elastomers. Usually thermoplastics provide a very good versatility basically, because here also we could see a very basic general purpose material to a very high end material, and also one of the good thing is it's a mostly recyclable materials are being used in thermoplastic materials. And in the case of thermosetting plastics, most of the materials are non-recyclable, mostly it goes to landfills. And in the case of elastomers, here it is a hybridization of both thermoplastic and thermosetting plastic we can consider. Certain elastomers are recyclable and certain elastomers are non-recyclable. And another point to be noted here is almost all the thermoplastic materials are polymerized during the raw material formation stage itself, whether it is a filament or a powder. So it is already polymerized, only the deformation occurs during the 3D printing process. But when it comes to thermosetting plastics, the raw material is mostly in the form of a monomer, and the polymerization reaction happens during the 3D printing stage. But in the case of elastomers, we have certain materials which is already polymerized, and we have other set of materials which is yet to polymerize during the 3D printing process. So we could see a variety of material and variety of category under these three itself. So let us move in detail with all the three category of materials. First one we will see is thermoplastic materials. Usually we have a very huge variety of thermoplastic materials which are available. So in that scenario, we could able to classify it on the basis of general purpose materials, engineering grade materials, high performance materials, flexible and elastic materials, and soluble materials. In that, these three are a type of material which is going to keep on being improvising its properties. But flexible and elastic, this material is a hybridization of both thermoplastic material and elastomer material. And in the case of soluble material, for the purpose of FFF technology, we create some support structures. That support structures need not be using the model material itself. It can be a soluble material, so that once the part is printed, it can be removed by dissolving the material in a water or any other particular solution. Now let us move in detail with the general purpose material. So what we could able to get from general purpose materials are, it will be giving us some less shrinkage and warping kind of issues, and it is actually a cost effective material for prototyping purposes, kind of visual prototypes we can consider, or a draft material we can consider. And we do not use these materials which is under general purpose for load bearing applications, and the temperature, that means the environmental temperature, it is restricted to 60 degrees Celsius approximately to 90 degrees Celsius. And the parts which comes from general purpose materials are almost like smooth and aesthetically pleasing. So we could able to get a good visual parts from these general purpose materials. And in the case of engineering grade materials, this provides a good amount of mechanical properties, that is like tensile, impact and wear resistant, and this could able to withstand the temperatures of approximately 100 degrees Celsius to 150 degrees Celsius, and this could provide some amount of resistance towards chemicals, oils and solvents, and this would give us a low creep under a sustained load, and these parts could be suitable for some moving applications or load bearing applications. Now coming to the high performance polymer, we could able to get a very huge amount of mechanical properties as well as thermal properties in the high performance category. This could able to endure around approximately 150 degrees Celsius to 300 degrees Celsius, and we could able to get a higher strength to weight ratio, that means even with a lesser component, I mean volume of the component, we could able to get a higher strength. And even for aggressive solvents or aggressive chemicals, acids or bases, it is very resistive. That means we could able to use it in a very harsh environments as well. And this materials meets a very stringent safety and standards for flammability issues, and this could able to give us a very less thermal expansion, which is suitable for very tight tolerances. And in the case of flexible and elastic materials, we could able to see it provides high elongation at break, and the shore hardness would range between 20A to 95A, and these parts are mostly used in high wear applications, and where repeated loads are coming, and where the frictions are higher, and these parts are mostly used in damping applications also for restricting the vibration and shocks. And also this provides very good resistance towards oils and greases. So this is mostly used in applications like gaskets, seals or O-rings. And coming to the soluble material, there are certain type of soluble materials which is dissolved in water, and other type of soluble material which is dissolved in limonene. In the case of PVA or BVOH, that is polyvinyl alcohol, and butanediol vinyl alcohol copolymer, we could able to dissolve that in water itself, but in the case of solvents like HIPS kind of material, that needs to be dissolved in limonene kind of material. And this material bonds well with the base material, that means the model material like PLA or ABS, and this is also environmentally friendly and soluble in water or other solutions, and we could able to get a very good smooth prints because it is easily removed, it does not make any damage to the model material. So this is a very good material when we want to get very intricate shapes, and it maintains the integrity until dissolution. That means it does not change its geometry until or unless we are moving it to either to water or limonene kind of solvents. Now let us see the different materials which are available under each of the category. So first one is PLA, that is polylactic acid, and we have ABS, acrylonitrile butadiene styrene, and then ASA, that is acrylonitrile stearyl acrylate, and we have PETG, that is polyethylene tetraphthalate glycol, and we have polypropylene PP. Then in the engineering grade we have nylon material, that is also called as polyamide, and we have PC polycarbonate, polyoxymethylene, and we have PE polyethylene. This could change between high density polyethylene and low density polyethylene also, and we have PMMA, that is polymethyl methacrylate, which is actually a clear material, that means we could able to use it for glass kind of structures. And we have PVC, that is polyvinyl chloride, and this material is very common in our day to day life, but in the case of additive manufacturing it is not a very common material, but it is in the experimental level only. We could see in the high performance materials, that is PBT, that is polybutylene terephthalate. Then we have PEK, that is polyether ketone, and we have polyether ether ketone and polyether ketone ketone. These PEEK materials are very common in medical applications because it provides a very high strength, and it's actually kind of a biocompatible material and used for implant kind of applications also. And we have polyetheramide PEI in the high performance category. Then coming to the flexible and elastic materials, we have TPU, that is thermoplastic polyurethane, which is actually a category under thermoplastic elastomers, that comes under elastomers as also. And we have another material called SEPS, this is also again a thermoplastic elastomer category of material, which is called as styrene ethylene butylene styrene. Then we have a material called PVA, that is polyvinyl alcohol, which is a soluble material and it is mostly used for PLA kind of materials because its temperature is limited to 180 to 200 kind of temperature. So, it is very easy to get it printed along with PLA kind of material. And we have HIPS, which is called as high impact polystyrene, and this material is soluble in limonene kind of solutions. And then we have BVOH, that is butadiene vinyl alcohol copolymer. Now, let us see in detail about these general purpose materials. The first material which we are going to see here is PLA, that is polylactic acid. Here we could see the raw material is in the form of filament, and the technology which uses that is FFF technology, and also we have SLA and DLP technologies which uses PLA in the recent time, and that uses resin as a material form for it. And in the case of ingredients, this is actually a renewable material because the raw materials for it is taken from cornstarch or sugarcane waste. The limitations here are, it is actually a prototype kind of material and it is not suitable for functional components. Then the next material we could see here is ABS, and in the case of ABS we mostly use it in FFF technology as a filament form, and here we have 3 ingredients, that is acrylonitrile, styrene and polybutadiene. And also people use it in SLS but in the experimental level, but in that case the material form is of powder. And we have a similar material that is called as ASA. Here we substitute polybutadiene with acrylate, that means acrylonitrile styrene acrylate. This material is used in FFF technology and filament acids raw material form, and both these material, that is ABS and ASA, one of the similarity is ABS material is suitable in the indoor applications for some limited load applications also, and in the case of ASA it is suitable for outdoor applications where UV light is exposed to it. And we could see both these materials requires a closed chamber for better build, and we have the next material, that is PETG. It is a usual material that is called as PET material, which we usually see it in water bottles, and along with it glycol is added, and so that we could able to use in the additive manufacturing. Here it comes in the filament form for FFF technology, but here we could able to get some challenges like stringing, which could be avoided by managing the temperature, that is the printing temperature and the speed. The next material here is polypropylene. Here we use FFF as the technology, again filament as the raw material form. Also this material uses in SLS technology in the experimental way as a powder acids form. And here what they do is polymerization of propylene monomers is being done, and the challenge we could able to face here is poor layer addition and warping issues. Now let us get into some engineering grade materials, that is first one we will see nylon, where we could see that nylon is mostly used in FFF technology as a filament form, and we have a variety of nylon categories available which exhibits different type of properties on different type of applications also. And we could see that SLS and MJF technology uses powder as the raw material form. MJF here is multi-jet fusion technology, and this material when using, it's mostly hygroscopic in nature. That means it could able to get moisture very easily. So we should maintain the material in a proper environment. The next material we have here is polycarbonate. In the FFF we have a commercial filament available, but in the SLS it's in the experimental stage. It's a combination of bisphenol A, that is BPA material, along with phosgene, but when we want to make the raw material in a safer way, then people will go for diphenyl carbonate, and this also requires a closed chamber for the better build. And the next material we have here is polyoxymethylene, that is used in FFF technology, and the material form is of filament, and we have the ingredient as formaldehyde or trioxane, through which the polymerization takes place to get the final product. This part is very difficult to get it printed due to its warping issue. The next set of engineering grade materials here we have is polyethylene. As I already told, this is available in two different categories. One is high density polyethylene and low density polyethylene. It differs from its usage also, but when it comes to FFF technology we require specialized printers, and also it is available in material extrusion kind of technology, where we use the pellets as a raw material form. This is basically derived from ethylene gas and to conduct the polymerization reaction, but it is very critical to get it printed due to its warping and low melting point and poor interlayer addition kind of issues. And the next material here we have is polymethyl methacrylate. The technologies here is FFF we use filament, and in the case of SLA we use the resin. And here the methyl methacrylate monomers are already polymerized for the FFF technology, but in the case of SLA technology the polymerization reaction itself takes place during the SLA process. And here we have issues during the printing, like it's brittle, so it might easily break actually. And the next material we have here is PVC. PVC is a material which is very experimental. It is not available very commercially. In the FFF also it is experimental, and in the case of material extrusion also it is experimental. In the case of material extrusion we use pellets, and in the case of FFF we use filament as the raw material form. And then this material actually releases a very toxic fume when it is heated. That means whenever it has to undergo the FFF or material extrusion kind of technology, the heating will be taking place, because of which toxic fumes will be generated, which is very hazardous. Now let us move into high performance polymer materials. Here we have PBT material, that is polybutylene terephthalate, which is used in SLS technology and FFF technology. In SLS it is in the form of powder, but in the case of FFF it is in the experimental level, and the material form is filament. This material is created using butanediol plus terephthalic acid, and we could able to get some warping issues, and even in SLS we need to make sure it is having a precise temperature control. The next material here is PEK. It is already in the experimental stage in the SLS, and it has got the powder as the raw material form, and it uses ketone and ether as the ingredients, and this is limited due to the high melting point and processing requirement. It is the same for almost all the materials in the high performance category, because this requires a very high level of machine setup which has got a very precise control of temperature and build chambers. The next material is PEEK, which is very common in medical industry, and we could see that FFF and SLS technology being used here. Same thing like filament and powder, which is the same for PEKK material also. And this material, as like already told, it requires a very specialized high temperature FFF machine basically, and the temperature, melting temperature reaches around 400 degrees Celsius, and also the build chamber need to be heated around 100 degrees Celsius. So we have to make sure the machine is very specialized, and in the case of SLS, we have to maintain a very precise temperature control. That means the laser has to be controlled very precisely. And we have PEI material, that is called as Ultem very frequently. We use FFF technology for it, and we use filament here. Then this also requires specialized FFF machine as like PEK and PEK machine. Then we will get into flexible and elastic materials. Here we have TPU material, which is which can be printed with FFF technology as a filament, and SLS and MJF in the form of powder. As like I already told, there is a thermoplastic elastomer kind of material which uses both thermoplastic material along with elastomer material. One of the critical thing in getting it printed during the FFF is it requires some direct drive extruder. That means we can't use a Bowden type extrusion system for this material, but we have to use a direct drive extruder on this. Then the next material is SEBS. We use again FFF material, filament as the raw material form. Again we have to use direct drive extruder for this material also because of its flexibility in nature, and it is also sensitive to UV light. The next category we are seeing is soluble materials. We use PVA material here, that is polyvinyl alcohol, and all the three materials you could see is HIPS, BVOH, all are used in FFF technology only and also as a support material, and all three are filament as a raw material form. One of the challenge here is managing the raw material, that is these materials are very sensitive to moisture, so that it requires a very controlled environment to store the material basically. And in the case of HIPS material, we have to have a machine which is having a precise temperature control, so that we can avoid the warping kind of issues. Now we shall see about thermosetting plastic materials, but in this case almost all the thermosetting plastic materials are photopolymer resins, and it is mostly used in material jetting technology and even SLA and again DLP kind of technology. In the case of thermosetting plastics, we have to understand there is no proper material name for this final raw material. It is an ingredient of different type of elements like epoxy, acrylic, polyurethane, vinyl ester, phenolic and cyanate ester. So these type of elements are added in different proportions to get our final raw material. Now coming to the final raw materials which is available, and it is not based upon the chemical name as like we have seen in thermoplastic materials. Here it is like the application name, like draft resin, clear resin, tough resin, durable resin, rigid resin and flexible resin. This is how the material manufacturers name the resin, because there is no particular proportion which is available for making the resin, and it is also very proprietary kind of thing, and they maintain it as a trade secret within them. So this is one of the composition on ingredients that is provided by Formlabs for a material called draft resin. Here we could see it is not made up of one single material, it is a mixture of multiple material. What we could see here is methacrylate monomers and urethane dimethacrylate, and the weight percentage here it is not provided in a single value, it is like a proportionate value where the percentages are also having a very big range. So we couldn't able to come up with a particular name on the material, and also this is the CAS number of the ingredient is also maintained as a trade secret, and we will be adding some photo initiators to it, so that when it comes to the polymerization reaction during the printing stage, this photo initiators release some radicals to start the photopolymerization, and also the solidification happens. Now based upon the application of materials which is available with Formlabs, we have found out that these are some common materials which is available in almost all the material categories. First one is methacrylate monomer, which is actually a primary building block in this material actually, and we could see its properties like fast curing, free radical polymerization, strength, hardness and rigidity in it. And we have methacrylate oligomers, and which acts as a backbone structure basically, that could able to provide some toughness, durability kind of property with it. And urethane dimethacrylate actually acts as a cross linker and enhances the mechanical property as well, and we could see a very good toughness, impact strength kind of and also chemical resistance with it. And acrylate monomer actually provides flexible material for it, and this provides quick curing, flexibility, low modulus, elongation with it. We have the next material, that is methacrylate ester monomer, that balances flexibility and hardness and provides moderate flexibility and low viscosity and processability and hardness. Finally we have the photoinitiator, which actually initiates the polymerization reaction, and it absorbs the UV light and generates the free radicals that generates the polymerization reaction. And with that in the mind, that means all the different type of materials. So this is how the material are created. So in the case of draft resin, they maintain the methacrylate monomer as 50 to 70% and urethane dimethacrylate as 30 to 50%, and less than 1% of photoinitiator is being added. And same way in the case of grey resin, there are different percentages of different things. It is based upon the requirement maintained by the application. That means in the case of a tough resin, there should be some mechanical properties of it. So that is why you could see there is a difference, higher value of urethane dimethacrylate is being added. But in the case of flexible material, you can see acrylate monomer is added higher, so that it could able to provide a higher flexibility. Same way you could see same amount of composition for this, only difference is there is no grey content added here in the clear resin. And let us go to the next one, that is elastomer materials. Here we could see the first one, that is thermoplastic elastomer, which we have already discussed for the case of flexible filaments in thermoplastic materials, which is mostly used in FFF technology and used in the form of filament. That is, we create that material by adding thermoplastic material with soft elastomers. The problem with thermoplastic elastomers is weak interlayer bonding, which actually requires a direct drive extruder, and this is actually the category under which TPU and SCBS material comes in. The next material we have here is silicon, which actually is made using SLA and DLP technology for resin, and in the case of MEX, that is material extrusion technology, we use it in the form of paste. And in the case of SLA and DLP itself, we use UV curing, but in the case of material extrusion, we use thermal curing. That means after the paste is extruded and made into a particular geometry, that is cured separately during the post processing. And in the case of challenges, we could see only specialized material extrusion and VAT photopolymerization machines are capable of handling this silicon material. Next one is nitrile rubber. Nitrile rubber is being processed using binder jetting technology, and it is in the form of powder. Here the raw material is acrylonitrile plus butadiene, and this material is UV and ozone sensitive, and also it has got a high temperature limitation. That means we cannot use it in a high temperature application basically. The next material here is polyolefin elastomers, where the technology is FFF and material extrusion. Here again we have the material form as filament for FFF and pellets for material extrusion. In this category, we could see that ethylene alpha olefin catalyst will be controlling the elasticity and softness basically. That means by varying the level of it, it will be controlled. And the challenges like it has got a limited chemical resistance, shrinkage and deformation after processing the material. And finally, we have flexible polyamide material, which is again a kind of thermoplastic material which we have already seen in nylon category, but here some additives are added so that we could able to get some amount of flexibility. We could able to do it in FFF technology as well as SLS technology. Same way in FFF we have the filament and SLS we have the powder. So here, as like I have told, we are adding some plasticizers or modifying the chemical structure of standard polyamide chains so that we could able to get some flexibility in it. As we have already seen, this is moisture sensitive, so we have to make sure it is stored in a proper environment, and this does not give a very high range of flexibility, it has got a very limited flexibility range. With this, we are coming to the end of our session. In this lecture, we have seen about different type of polymer materials in the case of thermoplastic materials or thermosetting plastic materials and elastomer materials. And also we have seen about how these materials are getting manufactured in different technologies of AM, and also its material form and its challenges also. In the next lecture, we will see about other materials in additive manufacturing. Thank you.